These are the frequently asked questions for pre-calculus for section 1, day 1. 12A says, according to the numerical model, what has been the trend in males joining the workforce since 1954? So what we want to do is go over to the table and just look from here on down and see what's been happening. And it started at 83.5, and we can see, at times, not down quite as much as the others. And in fact, right here we see that it went up a little bit. But it definitely has been decreasing overall from the 83.5 in 1954 to 71.9% in 2004. So that's what we would want to say, is that the percentage has been decreasing minus some minor fluctuations. So the trend itself was the percentage has definitely been decreasing, but there actually was a spot here where we found that it went up, and actually there's another one right here from 72.6 to 74. So there have been a couple instances when it increased, but overall from the 83.5 to the 71.9 in the majority, overwhelming majority of those 5-year periods that they're talking about, it has definitely been going down. So then B, in what 5-year interval did the percentage of men who were employed change the most? So what I'm going to do right now is I'm going to stop recording so I can grab my calculator and find all those fluctuations, or at least write those down for you so we can see those numbers. More clearly, the years where there was actual increase, there was a slight increase here, here, and here. Again, overall, it was definitely declining. And then B asked that 5-year interval where the percentage of men who were employed changed the most. So all I did was go through and subtract 83.5 minus 82.3, get 1.2. Move down to the next set, 82.3 minus 80.9, get 1.4. And the biggest increase that I found was a 3.3% increase as we go through that. And that happened from, or decrease I should say, from 76.5 minus that 73.2. And so that 5-year interval of that percentage, well, we'll go back over here, that would be 1979 to 1984. So our answer would be from 76.5 down to 73.2 in the 5-year interval. And that 5-year interval was, again, following it over in this direction, 1979 to 1984. And so it's almost as if you're kind of restating the question as you go through it. From 76.5, it was down to 73.2 in the 5-year interval from 1979 to 1984. So we're just looking at those differences for number 12, and that's just going to be us looking at the numerical data and coming back with an idea of what that data is trying to show us. So now you also had a question on number 13, where it said model the data graphically with 2 scatter plots on the same graph. One showing the percentage of women as employed as a function of time, and the other showing the same for men. Measure time in years since 1954. Well, because I didn't want you to have to sit and watch me do all this, I went ahead and entered in all that data into the graphing calculator beforehand. So now what we have to do is think about the windows that would be good. And our X value here is from 5 to 50. So if we go to our window, from maybe 0 to 60 would be a good way to see that. And then if we go back to that data, we want to find out, what were our percentages looking like. So we'll go back to, hang on, it's a little behind me again. That data and see that, well, we had a 32.3 up there. and we went all the way up into the 80s. Well, these were percentages. So technically for our window for the Y's, we could do 0 to 100. It's not going to hurt anything to do that because those were percentages. Now what we have to do is go into second y equals for stat plots. And in the first one, I'm definitely going to use, I'm going to turn that on, and I'm going to let it use list 1 and list 2. And it's just going to make marks. Now, this actually is the color calculator, so it is going to mark those as blue. If we want to see which one is men and which one is women, this one is women, we could just change it to little plus symbols, and I'll do that on the next one. So that will give me the scatter plot of the female data. Then I do second stat plot, and I go to the second set of stat plots, and I'm going to turn that on, but this time I want list 1 and list 3, so second 3. And like I said, this is color, but if it weren't, I could use little pluses to graph the men, so I'm going to go ahead and do that anyway. So there are the two scatter plots, and that would be the picture that you would want to put down on your paper to answer problem number 13. And then it said model the data graphically. Again, you're just going to show me a sketch of what you had there. Now, number 15 says, model the data algebraically with linear equations of the form y equals mx plus b. Write one equation for the women's data and another for the men's data. And it says, use the 1954 to 1999 ordered pairs to compute the slopes. So what that means is they want us to do this by hand. And the reason I know that is because they actually told us the 2 points that they want us to use. Now, of course, we can do that on the graphing calculator and get it more accurately, but we better follow directions at this point and do as we're told. So for number 15, if we want to go after the women's data first, we have to get the slope. And it said to use the points here from, that was 1954 and 1999. So let me get some of this off. So those would be our ordered pairs because we went 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. So we would have 0, 32.3 as our first point and 45, 58.5 as our second point. So our slope will be 58.5 minus 32.3 divided by 45 minus 0. So 58.5 minus 32.3 will give us 26.2, and we have to divide that by 45, and we will get 0.582 as our slope. And then I always like, if I have a choice, to use something that has a 0 in it in point slope formula. So y minus y1 equals m times x minus x1. Y minus 32.3 will equal 0.52582 times x minus 0. Well, x minus 0 is just x, so y minus 32.3 equals 0.582x, and then we'd have to add 32.3 to both sides. So that will give us y equals 0.582x plus 32.3 for our women's equation. Men's equation. Now the men, if we go up here, we see we're still going to be using the 0 and the 45.
Hey Alex, tablet cancer is tomorrow night at home.
All right, we're still using that 0 and that 45, but now we're changing to the male model, which will give us different y values. 0, 83.5, 45, 74. So we'll take 74 minus 83.5, and we'll divide that by 45 minus 0 to get our slope. So 74 minus 83.5 gives us a negative 9.5, and we have to divide that by 45, and that will give us a negative slope, which makes sense because remember, the men in the workforce were decreasing. And again, we're going to use that with a nice 0, so y minus 83.5 equals negative 0.211 times x minus 0, which is of course just x, so y minus 83.5 equals negative 0.211x, and then add the 83.5 to both sides, negative 0.211x plus 83.5. So that answered that question, because what we were supposed to do was come up with our equations for both the women and the men. Then, next on your list here was number 16. 16 says, if the percentages continue to follow those linear models we found in exercise 15, what will the employment percentages for women and men be in the year 2009? Well, to figure that out, we have to go back and say, you know what, the first year was 1954. And they want us to figure out 2009. So we're going to have to take 2009 and subtract 1954. All right, so back at it now that the bell is done ringing, and we wanted to figure out what's going on in 2009. And this started in 1954. And remember, we built our formula based on years since 1954. So we have to do this math in order for our formulas to work. And that means that our x value into each of those formulas has to be 55. So if we go back up to the women, it'll be y equals 0.582 times 55 plus 32.3. And let's see the percentage that'll come out of that. 0.582 times 55 plus 32.3. And that is approximately 64.31%. And then we're going to do the same thing for the men. We're going to put the 55 in for x and see what we get. So negative 0.211 times 55 plus 83.5. Obviously, very different equations, so we'll get a very different answer. Negative 0.211 times 55, and then plus 83.5. So that is approximately 71.895%. All right, and that was problem number 16. I believe you had one more up here. Yes, number 17 says, if the percentages continue to follow those linear models that we found in exercise 15, when will the percentages of women and men in the civilian workforce be the same? And what percentage would that be? Well, if we want them to be the same, we need to set them equal. So we need to go back to our formulas that we had for men and women. And if they're going to be the same, we're going to set those equal to each other, and we're going to solve. So let me get the smartboard to behave itself here. There we go. Here was our formula for the women. Here was our formula for the men. So the men at negative 0.211x plus 83.5 need to equal the women at 0.582x plus 32.3. All right, so next up would be to move our x's over to the same side. We would add 0.211x to both sides. So 83.5 equals 0.793x plus 32.3. Then we would subtract 32.3 from both sides. 51.2 equals 0.793x, and divide. And remember, as I'm punching this in, that what we're talking about for x is the number of years since 1954. So 51.2 divided by 0.793 is, well, 64.56. And 5 at the end, years. Now, because this is just a prediction, I mean, we can really just say about 65 years from now. So we take our 1954, which was the original date that they gave us, and we're going to add, well, 64 years, 65 years. It is just a prediction, and that gives us sometime during the year 2018. Now, what we want to be interested in after that is, so when is this going to happen? You know, we've got the 2018. What will it be? What will those percentages be? And because what we just did was solve, it doesn't matter which of the original two equations we put this back into. I think I will go ahead and put it back into y equals negative 0.211x plus 83.5. Because if it's a solution, it's true for both of them. So we can just take that 64, 65 and plug it into this equation. Negative 0.211 times 64 plus 83.5. So it would be approximately 70% sometime during the year 2018. And if we look at the book answers, you know, it says in 2018, and they went 69.9%, but if we go to the 3 decimals, there's our 69.96%. And there was one more that there was a question about, and that is 18, which it says explain why the percentages cannot continue indefinitely to follow the linear models that you wrote in exercise 15. We actually discussed this in class. As you look at the display from the graphing calculator, you see that the women, the blue little cubes or squares that you see up there, the trend is continuing upward. And eventually it would go over 100%, and we know that that cannot happen. The men, which are the little red crosses, are going down, and we know that we cannot have a percentage of men that is negative. So those are the two things that we need to explain. So the percentages for women cannot exceed 100%. The percentages for men cannot fall below 0%. So that's why they cannot continue indefinitely. Those were all of the questions that you had asked about 1.1 day 1.